Okay, now we see the validity. We want to ensure that our argument is true or false. And then for the valid, for the argument to be valid, if the hypotheses are true and the conclusion also true. The hypothesis and conclusion both are true. Okay, to prove the argument is valid, assume the hypotheses are true. Number one, we use the rule of inferences and logical equivalences to determine the conclusion is true. Okay, this one we have looked for last week. Recap chapter 1.2. Last week we have identity, we have domination, we have Adam Porton, we have double negation. Okay, and then we have commutative law, associative law, distributive, De Morgan. Okay, and then we have 10, exhaustion, and last one is negation, 9 and 10. Okay, for example, consider the following logical argument. We have hypothesis and conclusion. Okay, if P horses fly or cows eat artichokes. Artichoke ni apa dia? Artichoke ni ulam lah, ulam ke apa sayur kan. Then the mosquito is a national bird lah. Number two. If the mosquito is a national bird, number three, then peanut butter tastes good on hot dogs lah. Okay, number four lah. But peanut butter tastes terrible on hot dogs lah. We negate lah. Therefore, cow don't eat artichokes. We negate the Q. And then for the example, we want to assign the proportional variable to each component in the argument. Okay, we want to assign. Okay, this one after we assign a P, horses fly, Q, cow eat artichokes, R, mosquito is a national bird, S, peanut butter tastes good on hot dogs. Okay, and then represent the argument using the variable. Okay, we have P and or Q lah. Okay, or Q implies R, and then we want to derive R as hypothesis 1, and then for hypothesis 2, R implies S lah. Okay, and then we negate S. Okay, we negate S. Okay, and lastly, as a conclusion, we say that therefore we negate the Q lah. Cow eat artichokes. If cow doesn't eat artichokes, as a conclusion. Okay, here we have H1 and H2, and then we have hypothetical syllogism on 1 and 2. Okay, we eliminate the R, okay, to implies S, and then we have H3, negate H3. Okay, and then we have models tolerant on 3 and 4. 3 and 4 models tolerant. We want to affirm, and then we have a De Morgan law on 5, and then we have a simplification on 6. Okay, simplification on 6. Okay. Okay, for models tolerant, we want to derive something. Okay. For example, that we look before this, if you have a password, then you can log on to Facebook. P implies Q, and then you cannot log on to the Facebook, negate Q. Therefore, you don't have a password. This one is model stolen. Okay, for here we have P or Q is implies R, H1, and then R implies S for H2, and then we eliminate R, and then we negate the S. Okay, after we negate the S, and then we have negate Q as a conclusion. Okay, you can do both way lah. Either you negate first for H3, or you can go by the H1 first lah. It's either way lah. Okay. And then you go by the De Morgan's law on 5, because you open the uh, inner bracket inner bracket for negate P can have the or for the disjunctive should be conjunctive conjunction. Okay, and then we do the simplification. Okay, we simplify rule to derive the negate Q. Okay, okay, and then step by step. Okay, this one is okay, model stolen. Okay, okay, example we have P or Q implies I is hypothesis 1, R implies S hypothesis 2. We do the hypothetical syllogism on 1 and 2. Okay, because we want S, and then we have hypothesis negate S, and then we model stolen on 3 and 4. Okay, model stolen 3 and 4, P or Q we negate okay, because we eliminate this one. Okay, and then we go for De Morgan on 5. Okay, here operation, and then we go for the commutative on 6. Okay, commutative law, because we want the implication, or we want the conclusion as negate Q. We do the simplification on 7. We simplify. Okay, here we eliminate. Okay, we got our conclusion. Cows doesn't eat the artichoke. Okay, this one is reverse premises or statement. Okay, another example. If it is not a sunny this afternoon, and it is cooler than yesterday, this hypothesis. Okay, we will go swimming only if it is sunny day, P. If we do not swimming, then we take a canoe trip. If we take a canoe trip, then we will be home by sunset. Therefore, we will be home by sunset. Okay, do you have any question? Okay ke? Macam okay. Tunggu kejap Okay, we continue. This one is we have a hypothesis here, and then we have a conclusion here. Okay, if you do the rules. Okay, for the P, it is sunny this afternoon. P, Q, it is colder than yesterday, and then R, we will go swimming, and then S, we will go for canoe trip, and then T, we will be home by sunset. Lah. We have four here: H1, H2, H3, and H4. Lah. Okay, and then as a conclusion, we have a T. T, we will be home by sunset as a conclusion. Okay, this one is hypothesis, implies the conclusion. Okay, and then here we have a modus ponent. Modus ponent. Okay, for H1 and H2, we do the simplification on one. Okay, we simplified. Okay, and then we have a negate P. Okay, we modus tolerant on 2 and 3. And then we get H3. Negate R and negate R imply S is H3. And then modus ponent on 4 and 5. Okay, modus ponent. Okay, we eliminate this one. And then we have S. S imply T is for H4. And then we have modus ponent on 6 and 7. Okay, therefore we get T. Okay. Okay, we have modus ponent P. Okay, modus ponent P. And then we have P implies Q, and then we have Q because modus ponent we want to affirm only. Okay, so far do you have any question? Ada soalan ke? Yang ni kita tengok reverse balik kita punya kita punya we reverse back either we want to do the inductive or deductive lah. And then for H3 and H4, we do the hypothetical syllogism on 1 and 2. Okay. Okay, and then we go for H2, implication equivalence on 4, and then hypothetical syllogism on 3 and 4, 3 and 4, 3 and 5, sorry, and then we have H1, we go by simplification on 7, and then we modus ponent on 6 and 8. Therefore, we get the T. Okay, this one is same if we go by the R implies P. Okay, for H2 is equivalent to negate P implies negate R. This one implication equivalences. Okay, for the hypothetical syllogism, okay, we want to derive. We want to derive for the uh, we want to derive the P. P implies T. Okay, 3 and 5. Okay, we want to P implies T. We do the hypothetical syllogism. Okay, and then we go by the simplification. Simplification. Okay, simplification that we see P and Q is P. Here simplification negate P and Q. We have negate P. We simplified. We simplified the rule to derive the P. And then we have modest opponent on 6 and 8. Okay, 6 and 8 modest opponent. Okay, therefore we got the last one is T lah. Okay. Okay, this one rule of inferences for quantified statement. We have universal instantiation, universal generalization, existential instantiation, and existential generalization. We have PC is true. We select any element C and PC is true. Therefore, we have for all x px lah. And then for the existential instantiation, we have at least one specific C, whereby PC is true and so on. Okay. This one is a rule of quantified statement. We have four, 1, 2, 3, 4. Okay, for example, here we have everyone in discrete math class has taken computer science courses. Marla is a student in the discrete class, D Marla, and then therefore Marla has taken computer science courses as a conclusion. Okay, and then we can instantiate the by the using the universal instantiation. Okay, for H1. And then we can take the premises for H2, D as a Marla. Okay, and then we have a modest ponent using 2 and 3. Okay, for statement 2 and 3. Okay, we can have, we eliminate D, the premises, and then as a conclusion, we have a C Marla. Marla has taken computer science courses. Okay. Okay, this one step by step, and then you should have a reasoning. Okay, we have H1. Okay, and then we have H2. Okay, we have a universal instantiation on one. Okay, D Marla implies C Marla. Okay, and then modest ponent on 2 and 3. Okay, we eliminate the Marla, and then we have lastly we have C Marla, modest ponent. Okay, we want to eliminate. Okay, please do it is a student in this class has not read a book. Everyone in this class passed the first exam. Therefore, someone who passed the first exam has not read the book. Okay, this one for the exercise, please do in the Padlet. Okay, and then we have fallacies. Fallacies is resemble the rules of inferences, but based on the contingency rather than tautologies. Okay, what is contingency? Contingency, all of the not all of the value are true. Okay, we have false and then we have true value. Okay, and then tautology, all of the truth value are true. There are incorrect inferences. Okay, we can question what for the inferences. And then three common fallacies that can be occur. First one, affirming the consequences. Secondly, is denying the hypothesis, and then thirdly is circular reasoning. Later we discuss this one. Yeah, so far do you have any question? Ada soalan ke setakat ni? Ada, okey boleh. Nanti yang statement tu nanti kamu just reverse the apa conclusion tu, kamu akan dapat dia punya ni lah, dia punya hasil dia. nanti kita akan buat latihan lagi lah. Jangan risau yang tu. Okay, fallacies yang fallacy ni assumption or series of steps which seemingly correct but contain a flawed argument, which mean that some of the inferences are incorrect lah. Okay, okay, it contain the flawed argument lah. Fallacies contain the flawed. Okay, flawed argument lah. Dia ada error dia ada error dekat argument tu, uh, tak betul lah. Sama ada argument tu tak betul ataupun kita nak deny argument tu. We want to deny the argument. Okay, and then for the third condition, we begging, we requesting the question in both two different way. Okay, for this one. For example, fallacy of affirming the consequent is we have the P implies Q and then Q and then therefore we have P. P is not a tautology and therefore not a rule of inferences. If you do every problem, then you will learn discrete mathematics lah. Okay, this one we have a modus ponens. Okay, because we want eliminate the Q. And then the second one is modus tollens. Okay, modus tollens. We negate. Okay, negate the premises. Okay, P implies Q and negate Q implies negate Q. Okay, P we negate P and then we negate the Q. And then it is not also a tautology, therefore it's not a rule of inferences because the rule of inference must be tautology. Tautology must be true. Okay. And then we have circular reasoning. Okay, one or more steps are proved are based on the truth that statement being proved, also known as begging the question. For example, if we have A and B, we say if A then B. You can say also if B then A. Okay, we beg the question, and then we begging the question both way. This one both way. Okay, either A or B lah. Boleh ke? Begging the question. We dia kita boleh request either one. Or the other word you can say that it can restate or presupposes the claim. Kita boleh claim sama ada A dan B ataupun kita boleh claim if B then A. Example untuk begging the question, everyone want the new iPhone 13 lah contohnya because it's the hottest gadget on the market. Okay. Lagi if the iPhone is a new gadget, then it is the hottest lah. Kasih songsang je lah. Sama ada songsang ataupun tidak lah. You can say if the new gadget on the market, you can know the iPhone is the hottest lah. Ataupun kamu boleh kata everyone want new iPhone because it hottest new gadget on the market lah. Dia either way lah. Or you can say that arguing in a circle. kita boleh argue dalam circle lah, because this one is a circle lah. Okay, boleh Okay, and then we take a look of method of proof. Kita ada 2, 4, 6, 7 indirect proof, vacuum proof, trivial proof, proof of contradiction, proof of cases, and existing proof lah. Okay, for the proof basic, we want to conjunctive use the conjuncture until the proof is produced lah. Okay, and then we may produce a truth table. Okay, and then for direct proof, how to prove if P is true, then Q has to be true if P implies Q to be true. For this example, the proof that we did earlier about the cows, not eat artichoke, was an example of direct proof. Okay, direct proof means you need to be logic. Okay, logic and establish. You want to prove by using the modus ponens and modus tollens to affirm and to de-affirm. And then we have example, if n is even, then exists an integer k such that n equals to 2k, it is odd. Then if there exists an integer k such that n equal to 2k plus 1. For this one, you need to insert all of this in the statement. Okay, for example here, we have for some k, n equal to 2k plus 1, you put in the conclusion for n power of 2 is odd, and then you can say 2m plus 1 where some integer m equal to 2k power of 2 plus 2k. Since 2n power of 2 okay plus 1 and then n power of 2 is odd is true, then the proof is complete lah. Okay. Okay, you need to prove lah. Okay, by producing the equal statement. And then we have indirect proof, which is a contrapositive. If you want to be contrapositive, you have to negate the condition. Assume the negate Q is true, Q is false. Use the rule of inferences and logical equivalences to show that negate P is true. For example, P is false because we negate the condition or the premises. Okay, for example, we have here 3n plus 2 is odd. Okay, n is odd lah. Okay, in other words, we can say n is even implies 3n plus 2 is even lah because we negate the apa the premises. Okay, for this one, assuming the hypothesis of contrapositive, n is even lah. Okay, and then now the conclusion for the contrapositive is true. You need to prove by using the statement this statement. Okay, you need to put 3 2k representative plus 2 equal to 6k plus 2, then 2 3k plus 1 and 2m where m is equal to 3k plus 1 Okay, proof is complete Okay, and then we have vacuous proof, have two uh, condition. First one, if we know that hypothesis P is false, then P implies Q is vacuously true because both false implies false are both true and false implies true. Okay, is true. Okay, for example, I am both rich and poor. Then Hurricane Kane was a mild breeze. Okay, sometimes we want to use the universal quantification to represent the vector proof. Okay, another example, we have P, 0 is true, whereby Pn if n greater than 1, if then n great power of 2 greater than n. For example, if we have 1, is it 1 greater than 1? No lah. Okay. Is it 2 greater than 1? Yes. Then 2 power of 2, 4 is greater than 2 lah. Okay, and then we have trivial proof is different from the vacuous proof because for this one we have false implies true and true implies true are both true. For this one is for vacuous false implies false. Okay. Okay, and then for example, if it's raining today, then the empty set is a subset of every set, and the assertion of trivially true is independent of the value of p. For example, here, suppose P0 is true when Pn if A greater or equal to B greater than 0. Okay, for the trivial proof, we need to have the hypothesis, okay, and the conclusion because it is independent. Okay, and then we have a proof by contradiction. This one is find the contradiction, and then we show the contradiction is false. So P is true. Okay. Okay. This one is example. Prove that the power. What is this? Kalau ni and power of two. Kalau yang ni, the factor. Factor. Okay. Prove that the factor two is irrational. What if negate P? Negate P is true, and then uh, the power source of 2 is rational. Does lead to the contradiction. Okay, if this one is rational, then for some A, B integers like that, uh, the power of 2, the source power of 2, A uh, divide by B have no common factor. Okay, this one is example for contradiction. We contradict for both statement. Okay, for example, we have even 2 power b2 for some integer c, and then we have the so b equal power of 2 is equal to c power of 2 lah. If b and if a and b are even, so they have at least one common factor. At least one common factor. So the assumption R is contradicted. Therefore, negate P is false, P is true. So the power source of 2 is irrational, it is true. Okay, so far I think that's all for today. We can take a look next week for the assignment. Assignment kita akan tengok minggu depan. Kalau ada apa-apa soalan nanti boleh tanya and then please do the group creation by putting your names in the WhatsApp group For example, you have group 1, let's say Huda and Cindy, group 1, and then continue by group 2 and so on lah. Boleh?